we'll be glad to do that. That's Bill Wynell, W4WXW, who I met at WRAL TV a good number of years ago. He came to work sometime after I did. I had moved on to the transmitter, and he ended up at the studio. And one thing I remember very well is back before we had everybody online on the internet, Bill ran a bulletin board where we could all dial into using a US robotics modem, if I remember that right. But Bill's done quite a variety of stuff at WRAL and was very good at it. And he's got to retire now, and he'll show us some of the stuff he's done and has. And he's got a nice shop, and I get a kick out of hearing him tell what he does each Saturday morning on the net. So, Bill, go ahead and tell us what you would like. We appreciate you being here today.
Yeah, okay, fine business there, Charlie. I hope everybody can hear me. I'm going to, this presentation today, I'm going to go over is on tools for the electronics workshop. And I'm going to go ahead and share my screen, if that's possible. Looks like I've disabled at the moment, so maybe somebody will give me a sharing ability here in just a minute, and I'll be able to do that. But at any rate, I do quite a bit of electronics repair work at home, and also some electronic design. And it's one of the things I've always loved to do since I was, oh gosh, probably back in junior high school. I started getting interested in electronics back when I was probably 10 or 11 years old. And back in those days, we listened to a lot of shortwave radio, which I'm sure a lot of you are familiar with. And that's one of the things that really got me started in amateur radio and started in electronics in general. And I used to hear a lot of the big amateur stations talking on AM on 75 meters at night. And I used to get a kick out of that. Learned quite a bit from listening to those guys. And that sort of led into a career with broadcasting. And I later went on and got a first-class commercial license. Worked in the broadcasting business for about 43 years, primarily at WRAL, but also at a couple of other stations. Took a short stint over at the U.S. Environmental Protection Agency, actually working in a field in which I have a degree, which is computer science. And it was the most boring thing that you can imagine, because basically I ended up being computer support for much of the EPA across the country. So a lot of times you just sit behind a desk and do nothing but talk on the phone. So
Bill, hey Bill, you should be able to share your screen now.
Okay, thank you, Tom. I appreciate that. So we'll go ahead and do that. And there we go. And I'm going to go ahead and see if I can get my presentation started. This particular presentation is going to be on tools for the electronic workbench. These are tools that specifically I use in my shop, but probably many of you will need in your shop or maybe use in your shop. And the way this presentation is set up, it starts from the most basic tools in the workshop, which probably a lot of you already have, all the way up to some more advanced tools. And I basically took it from the point of somebody who's just first setting up an electronics workbench as to the things that they might need for their workbench. So let's go ahead and see if we can get started. So this is basically, as I said, an overview of tools that are used to service radio and electronics equipment. The workshop environment is very, very important for servicing. The following items are what you need in order to accomplish a good workshop. You need a good solid surface workbench. A Formica countertop is optimal. However, you can use what they call hardboard or melamine or maybe even just wood if that's all you got. But it's kind of nice to have a solid surface to work off of. Probably the most important thing about the workbench is you want to make sure that the workbench is at a comfortable height for you to sit at and work without being hunched over or without having to strain to look up at what's going on the workbench. I find 28 to 29 inches off the floor to be about optimal. About 2 feet deep is about what you want, and my typical workbench is about 4 to 5 feet long. Good overhead lighting is a must. I like the LED overhead work lights. I think the one that I use on my workbench is actually from Harbor Freight. They're not very expensive. I think you can get them on sale for less than $20. So that's a good thing to have over your workbench. It provides plenty of light, doesn't have a lot of heat, which is one of the problems that you used to get with quartz type lights. Workbench AC power distribution. I like the power strips that have switches on them. That way you can plug all your gear into it, particularly the gear that you're testing, and you can turn it off with just one switch. So, you know, if you end up having a problem or something starts to burn up, you don't have to go fumbling for power switches. You just know right where to go to kick that switch off, and you don't end up damaging a lot of stuff. A comfortable office chair is important. You want something that's the optimal height for the workbench. Like I said, about 28 to 29 inches, so that your arms are resting on the bench and you're not hunched over. Visual aids. The older I get, the more visual aids I need, as I'm sure many of you do. I like the headset magnifiers, which you can pick up from Harbor Freight for, I think, less than 10 bucks. I think they're somewhere around $5 or $6. Those are very, very useful when you're working on equipment on the bench, circuit boards or in chassis and things like that. Handheld magnifier lights are very good, or even handheld magnifiers. And another thing that I use quite a bit is I use a handheld LED work light that's battery powered, that I can actually get down inside of a chassis and see what's going on if there's an item that's shrouded in darkness there. The light's not getting to it. Finally, one of the most important things which people neglect is static control on the bench. If you do any kind of work on solid state gear or even some tube type equipment, you can have static discharges which can damage the semiconductors in those units. So you want to have good static control in your shop. That's particularly important in the wintertime when the air is real dry. Fortunately, we have a very good place to get static control equipment from here right down in Sanford. Static Control Systems actually manufactures a lot of the anastatic workbench equipment down in Sanford, so you can buy it directly off of their website. They used to be owned by 3M. I think now they're owned by another company. I think it's Desco is who owns them. But if you look up Static Control Systems on the internet, you will find them. And what I like is I like their work surface mats that you can roll out on the bench. They have a ground connection that you can provide. You can hook to a ground bar or your local ground in your shop. So those are all of the various things that I consider essentials in the electronics workbench. There are a number of category tools that you use when you're building or servicing electronic equipment. Some are necessary, some are optional, but they're likely to make your job easier. The broad categories of tools that we use are hand tools, mechanical tools, soldering tools, measuring tools, specialized tools, and expendables and discrete components and workshop organization we'll cover at the end of the presentation. In basic electronic hand tools, the most basic tools that we use are pliers, probably pliers, screwdrivers, nut drivers, strip tool, handheld helping hands, soldering irons, and digital multimeters. Those would be the basic tools that you need for the electronics workbench. In each of those categories, you can see it's broken down into the items which I consider to be very essential for the basic electronics workbench. You need a good pair of diagonal cutting pliers and a good pair of needle nose pliers and pliers. You need both standard and precision screwdrivers. You need English and metric nut drivers. One of the most important things that people overlook is the strip tool. A lot of people use diagonal cutters or even knives or razor blades to strip wires. I don't recommend that, because if you strip a wire with a knife or a razor blade or a diagonal cutter, many times you'll nick the wire while you're stripping. And once you nick that conductor, when you bend it a few times, it's going to break. And so that's going to cause you a problem down the road. So be sure you use a strip tool when you're stripping wires on your workbench. A helping hand or vise, very, very essential piece of equipment to hold parts while you're working. Of course, soldering irons you need to make electrical connections, and DVMs you need for making the necessary electronic measurements. Some of the particular items that we discussed in the basic electronics workbench are pliers. These are a selection of pliers that I use in my shop, all the way from square nose electrical pliers all the way down to on the very right-hand side, the printed circuit board needle nose pliers. In diagonal wire cutting pliers, the same thing there, pliers. Also diagonal wire cutting pliers for doing heavy electrical work on the left, all the way down to the chain nose cutters that we use for doing circuit board work on the right. In screwdrivers, these are some of the screwdrivers that I use in my shop. The essential ones are probably the number 1 and number 2 Phillips drivers, and then the 5/16 inch and down slot drivers. You'll also notice there that there are a couple of a couple of drivers there on the, I think the one on the very right side, that is a reversible screwdriver. Those are very handy when you're doing work away from your workbench, out on an antenna or out in the field, so that way it'll take the place of 3 or 4 different screwdrivers, and you don't have to carry a whole bunch of screwdrivers with you. And then also I've mentioned there, you have the stubby screwdrivers up there at the top. Those are essential for getting into tight spaces where you may have to not be able to get a regular screwdriver into it. Nut drivers, typically these are all of my English drivers. They go from 1/2 inch down to 3/32. We need those for getting in and loosening machine screws and things like that when we're working on electronics equipment. Wire strippers, which I talked about a few minutes ago, the wire stripper on the left and this one here and the wire stripper in the middle. These wire strippers basically are the ones I use the most often. They're actually set up, they have striations in them, which you probably can see there in the photo. The photo is not too good, but each one of those is for a different wire gauge. So this allows you to strip the wire without nicking the conductor. The stripper that's on the right is a production stripper. If you strip a particular size of wire quite a bit, you can set that production stripper up so that you can use it all the time. I believe that one is set up for 20 gauge because that typically is the wire that I use most for general hookup wire. That's very important, once again, if you're stripping solid core wire, because if you end up nicking it, then it's going to cause you a problem down the road. These are helping hands, which are handy to have on your workbench to be able to hold things while you're working on them. The helping hand that's on the right there actually has a little magnifier on it, which is good if you're working on something small. You can actually see a little bit better what you're doing. And then finally, soldering irons. These are all standard 110 volt or 115 volt AC soldering irons. The most important thing I'll mention about these particular soldering irons is that they're all temperature control soldering irons. And they're also interchangeable tip soldering irons. Many people, when they go out and buy a soldering iron, they just go buy a standard soldering iron that's used for, general purpose soldering, like soldering gutters or things of that nature. Most of the time, those aren't temperature controlled irons. If you try to use those in some types of electronics, you can end up damaging things, particularly if you're trying to do circuit board work. So you want something that's temperature controlled, that won't allow the tip of the iron to get too hot and end up lifting copper off the circuit board, or end up damaging components, which you can also have even in a chassis. And then finally, you need a good digital multimeter. This is the one I typically use the most often. It's a Fluke 77. It does current and AC and DC voltage, as well as it has a semiconductor junction tester in there, and also has an ammeter in there that allow me to read current up to 10 amps. So those are the basic tools that you would use in the basic electronics workshop. All of those previously listed tools will allow you to do some minor repairs on your electrical and electronic equipment around the house, as well as constructing simple electronic and antenna projects. However, and they may be all the tools you need. However, by adding some additional tools to your workshop, you can take on more complex projects. So let's look at some of those additional tools that we might use. The additional tools that we might want to add to our workshop would be specialty pliers, in this case, hook nose, snap ring, and electrical pliers, tweezers and hemostats. Tweezers and hemostats are very, very good for holding and working with small parts. They're also good for heat sinking components when you're soldering, because particularly some solid state components are susceptible to heat. So you want to be able to drain that heat off the lead when you're actually soldering it. Crimp tool for crimping terminals, something a lot of people have, but it's a very handy thing to have around in your workshop. Wrenches, primarily ignition wrenches and Allen wrenches, though it doesn't hurt to have some standard box end wrenches around as well. Files, probably needle files and standard files for smoothing and enlarging holes. And then you probably also want a breadboard if you do any circuit prototyping or testing. That allows you to quickly prototype a circuit and test it on the bench before you actually wire it up and install it in a piece of equipment. So let's go look at some of those tools. On the left are a set of snap ring pliers, both inner and outer snap ring pliers. Those are handy for removing snap rings and equipment. You find those in a lot of older radios and stuff, in linkages and things of that nature. And then hemostats in the middle. Primarily I use these for holding small parts and for heat sinking, as I said earlier. And then on the right, some of my tweezers, a lot of these are used for SMD work. I'm not going to go into SMD specific tools today because that's a whole different category and it's sort of a specialized category. A lot of people don't work on SMD, so maybe it's something we can look at later if there's any interest there. In wrenches, these are some of the wrenches that I use in my workshop. A particular note are the ignition wrench set over here. These I probably use the most often because typically they fit most of the machine hardware that's most common in electronics equipment. And then, of course, just to the left of that's a Vaco crimp tool, which we can use to crimp terminals on with. It also has a wire stripper on the back side of the tool as well that will strip some of the more common gauges of wires without nicking the conductors. And then, of course, standard box end and adjustable wrenches over here, which may or may not be useful to you depending upon what you work on. Allen wrenches, this is something that you probably need in your workshop if you're going to work on electronic equipment, particularly older electronic equipment, because many of the knobs and linkages in the equipment use Allen set screws to actually hook those linkages together or to hold knobs on the equipment. And so if you don't have a good set of Allen wrenches, you're going to have a difficult time servicing that gear because you're not going to be able to remove those knobs, or you're going to damage them when you do remove them. And then needle files and standard files. Always good to have a good set of files around, particularly if you do any construction at all. However, they're also good for repairs, like if you have to replace a potentiometer. Most potentiometers have long shafts on them. You end up having to cut the shaft off, and then you're going to have some way to deburr the shaft. So you probably need some files around in order to do that. Let's go down to the next section that we're going to look at, which is mechanical tools. Mechanical tools are primarily used for machining and mounting electronics and fabricating enclosures. In the mechanical tool category for the basic workshop, we have knives, a nibbling tool, hot glue guns, tap sets, socket sets, and a rotary tool. So those are all the basic tools that you would use in the basic electronic workshop. They're all useful for mounting components and for assembling and machining enclosures for components and things of that nature. So let's look at some of those. On the right, this is a tool that you may not be familiar with. This is a nibbling tool. A nibbling tool allows you to nibble out non-round openings in metal up to, I think, 3/16 of an inch. So it's a very handy tool to have around if you do enclosure fabrication. In the middle, there's a hot glue gun, something a lot of you may be familiar with. That's a handy tool for the electronic workbench because if you don't have any other way to stabilize a component in a chassis or something, you can put a little dab of hot glue on it and stick it to the chassis or the enclosure, and that way it'll stabilize it and prevent it from moving around. And then finally on the left is a standard razor knife, which I'm sure a lot of you are probably familiar with. It's just good for general purpose cutting. The tap sets that I use in my shop, I have both standard and metric tap sets. These are useful for chasing threads and doing things of that nature. Occasionally I'll have to thread a shaft or something like that. But most of the time I'm just repairing threads when I'm using the tap sets. A socket set, this is just my general purpose socket set that I use around the shop. Sometimes a box end wrench isn't sufficient to do the job, so we have to go back to the sockets. Of primary use in the electronics side of things are the small sockets or a 1/4 inch socket set. Those are useful for machine screws and electronic servicing. This, of all the mechanical tools, this is probably the one that I use the most, which is a rotary tool. The rotary tool comes in particular handy for machining plastic enclosures, drilling holes, drilling holes in PC boards, particularly useful for that, and actually doing plastic machining, which you can use the flexible attachment for over there. Okay, other mechanical tools we may use in the workshop, locking and slip joint pliers, metal cutting tools, an electric hand drill, a drill press, and digital calipers. So let's look at some of those. In locking and slip joint pliers, probably a lot of these you're already familiar with. On the right are your slip joint pliers, and on the left are your locking pliers. They're useful for holding things or taking things apart when you have to apply a lot of force to it. Every once in a while, something will get stuck pretty bad, particularly if it's been outside for a while, and you'll have to put some force to it to get it loose. So those are good for that. Metal cutting tools, these are primarily things that I use for fabricating enclosures and for cutting straps and things of that nature. And then, of course, an electric hand drill, an indispensable tool if you're fabricating enclosures to be able to drill holes. And then the drill press. Didn't really realize until I got a drill press how useful these are. They're very good for precision hole drilling as well as tapping. The neat thing with using these with taps is that you make sure that the tap is exactly at a 90-degree angle to the workpiece that you're tapping. So you can actually put the tap in the chuck and actually turn the chuck by hand and end up getting a perfect tap on something. So that's a real neat thing as compared to trying to use a hand tap. And then probably the most important of all of these tools is a digital caliper. These are typically available from Harbor Freight for less than $10. This is an essential tool in the electronics workshop, particularly for measuring things, because I'm all the time having to measure component lead distances and lengths of screws and machine fasteners and stuff like that, or diameters of machine fasteners. This allows you to get an accurate measurement on those. So this is a tool that's very inexpensive and very good to have in your workshop. Okay, let's go to soldering tools now. In soldering tools, the tools that I use in my workshop in soldering are listed below. That's the temperature control soldering stations. I use those for printed circuit board work as well as general soldering. A soldering gun, which I use for high heat applications when you need to put a lot of heat on something real quick. Of course, solder, you got to have that if you're going to work on electronics equipment. Most of the time I use 60-40-10 lead. However, there is lead-free. Some devices now use lead-free solder. The solder I use most is probably Kester 44 .031 diameter. That's the most used solder around the shop here. Rosin activated flux, not something a lot of people use. However, it's something I recommend highly. It makes your job of soldering things a lot easier. As most of you know, probably from past soldering, solder has flux already in it. However, a lot of times it's helpful to be able to apply additional flux to something to help the solder flow better. And so having some liquid rosin activated flux around is very, very handy, particularly when it comes to desoldering. That's one of the places I probably use it the most. And then also in the desoldering category, solder braid. Very, very useful for removing solder along with the rosin activated flux, because it'll tend to wick up solder once you get it hot off of a circuit board or out of a plate through hole or things of that nature. And then below, the three items below are also what I consider essential for soldering, which is a cleaning sponge, an iron tip cleaner, and then tip tinner cleaner. Those are for maintaining the tips on your soldering iron. It's important to keep a good tip on your soldering iron and to maintain the life of the tip, because it basically doesn't transfer heat efficiently once that tip gets dirty or starts to pit. So you want to make sure you keep your tip clean all the time. You keep your tip on your iron tinned, and you make sure that it's going to transfer heat efficiently. Okay, in my workbench, here's some of the tools that I use for soldering. Those are my two main solder stations on the left. I also have additional solder stations that are used for more specialized purposes, but these are the two that I use the most. On the left is a Weller TCP. That's a temperature controlled soldering station. That particular station I primarily use for surface mount work, because it's got basically surface mount tips in it. Then in the center there is a Edison Loner 951. That's my general purpose soldering station that I use for everything. And as you notice there, it's temperature controlled. So I can actually set the temperature exactly where I want it to be for what I'm working on. That way you make sure if you're working on something delicate, you don't get it too hot. Or if you need more heat for something that requires more heat, you can turn the heat up on it. Also, I have a solder fume extractor there that I use whenever I'm soldering to actually pull the rosin fumes away from me, so I'm not breathing those in, because it's not something you want to breathe in all the time. It's probably not very good for you. And then, of course, down in front there is my bottle of rosin activated flux, a couple of pieces of braid that I use for desoldering, and one of my tip cleaners, along with some solder. Oh, one other thing I'll say on this particular slide, you may also notice that this blue work surface down here, that's the Static Control Systems anti-static mat, which I keep on my workbench. And so that means whenever I'm working on something, it's sitting on a grounded anti-static mat, which is kind of very handy, particularly in the wintertime when you got static discharges being a concern. The other two soldering tools that we didn't mention that are handy to have around is a vacuum desoldering pump. There's actually two types of vacuum desoldering pumps. There's manual vacuum desolder pumps, and there's electric vacuum desoldering pumps. The electric pumps are are fairly expensive. They're primarily used for multi-layer printed circuit boards and high volume applications. However, if you do a lot of desoldering, it's a very handy tool to have around your shop. This is the tool that probably most of you will be familiar with, and I use this tool quite a bit. I've had this particular tool for over 30 years. This is an Edison desolder tool, and it's very good for removing solder from terminal strips and terminal boards and chassis, and even on printed circuit boards. However, it usually will not pull all of the solder off the board. That you end up having to use braid in order to actually pull some of the solder out of holes and things like that. Still a very useful tool to have around the shop, less than $20, something I highly recommend to people. This is an example of an electric desoldering tool. This is a Hakko 808 production desoldering tool. This is mine. I use it for when I'm doing multi-layer printed circuit board work. It's temperature controlled, and so you can do a lot of desoldering with it without damaging plate through boards. As you see also there's a needle applicator with rosin activated flux and a tip cleaner that comes with it. Because once again, it is very important to keep those tips clean on your soldering equipment. Okay, let's go down to basic electronic measuring tools that we use in the shop. Of course, one of them we've already covered, which is the digital multimeter, which you need for making measurements in your shop. Some of the more specialized measuring tools you may want to have in your shop is a vacuum tube voltmeter. If you do any work on high voltage circuits or high impedance where you need, or high impedance circuits where you don't want to load the circuit down, you want a vacuum tube voltmeter. One of the failings of digital multimeters is they're low impedance devices, and they do put some load on the circuit. So if you're working with a high impedance circuit, you definitely want a vacuum tube voltmeter to do your measuring. An LCR ESR meter, that's an equivalent series resistance meter. That's for testing capacitors. As most of you probably know from your amateur licensing, capacitors are probably the most likely thing to fail in any electronic circuit. Many times a capacitor will fail. It'll look fine when you observe it on the outside, but it can be failed. And so you want a way to actually test the equivalent series resistance on that capacitor and to test the capacitance value on the capacitor. An LCR ESR meter does just that. If you do amateur work, which I'm sure many of you do, you need a good RF power meter for making transmitter measurements, and also a good field strength meter for checking for transmission line radiation and for checking for antenna radiation. So let's look at some of those particular tools if you're not familiar with them. Of course, the DVM we've already looked at. Once again, that's my Fluke 77. This is a good example of a vacuum tube voltmeter. This is a triplet 850. This particular vacuum tube voltmeter will measure up to 1500 volts AC or DC, and it also will do ohms, and it also will do peak to peak AC, which is very handy. And once again, it's a high impedance meter, so it doesn't end up loading the circuit down. Also useful for audio measurements as well, since it does peak to peak AC. This is my one of my LCR ESR meters. This is a DER DE5000. This is an automatic LCR ESR meter. Basically, all you have to do is plug your capacitor into it. It'll tell you the value of the capacitance and give you the ESR reading on the capacitor, which will give you a quick look at whether the capacitor is good or not. I primarily use this meter out of circuit. You can do in-circuit testing with this meter. However, the results are not as accurate. And I primarily, like I said, use this for out-of-circuit testing. It's particularly good for grading components. When you buy components in large volumes from surplus dealers and things, it's handy to be able to test those components before they go into your stock, so that way you know that they're good before you put them in the stock, and you don't end up grabbing a bad component off the shelf to actually repair something. RF power meter, this is a Swan WM1500, goes up to 1500 watts. I use this on my bench for transmitter alignment. And then for field strength, this is just a little Midland field strength meter. It also does SWR. You've probably seen these for years. I think these were made real popular back in the 70s, but this is real handy for doing field strength measurements and for checking for feed line radiation. All right, now we're going to roll up to the specialized electronic tools. These are tools that not everybody may need, but depending upon what you do, you may end up finding them useful. In the specialized electronic tool category, we have bench power supplies, both low voltage and high voltage, RF and AF signal generators, which are useful for troubleshooting, alignment, and signal tracing in equipment. an oscilloscope, which is also useful for signal tracing and alignment of equipment, a frequency counter for identifying the frequency of signals in equipment, the spectrum analyzer, that's useful for signal identification and network filter analysis. Transistor testers, useful for in and out of circuit transistor testing, an inductance meter, which is useful for testing and identifying coils. And then let's see, the two items next are basically useful for vacuum tube or older equipment repair, which is a variac that allows you to vary the AC voltage going into a particular piece of gear, and an AC current limiter, which allows you to limit the current going into a piece of equipment. Particularly useful if you're working on older equipment. And then finally, a signature analyzer. The signature analyzer is a device that I've only started using in the past couple of years, but it's very, very handy for quickly identifying bad components in a circuit. In fact, one of the things I'll say about the signature analyzer is you don't even need to know what the circuit diagram is or what that circuit is doing in order to use a signature analyzer. It basically allows you to test components on a component by component basis. And many people may know this as an octopus, what's known as an octopus. And if you are interested in that, you can go do a search for octopus or signature analyzer on the net, and you'll find a whole lot of information about it. So in those particular areas, this is my low voltage power supply that I use for general breadboarding. It's a 28 volt, 2 amp variable over voltage, over current power supply. Handy to have around for use with a breadboard when you're testing circuits or designing circuits on the bench. This is my high voltage power supply. This power supply, I think, will go up to 400 volts. And it has a B plus supply in it, as well as filament supply for doing tube circuits and working with tube circuits. This is an example of an RF signal generator. This is my Marconi 2018. I use this for general purpose signal generation around the shop. I do have another signal generator, which I think I had said earlier this morning is still still belly up. I'm still working on fixing it. It's got a PLL problem. Fortunately, I do have two of them, so that's good. And I use this for alignment and for network and filter work. The scope I use most in the shop is my 465B. Tektronix 465B. It's an older scope. It was popular back in the 70s, but it's still a good scope to have around the shop. It's got 100 meg bandwidth. This particular one has the DM44 option on it, which allows you to do time measurements and voltage measurements as well. Frequency counter, this is an HP 5303. It goes up to 50 megahertz. I find most of the work I do is 50 megahertz and below, so this one works fine for me. And this is just showing you the 10 meg internal oscillator in there, which is about 1 hertz low. This is my spectrum analyzer. I use this. It also has a tracking generator on it, which you see up on the top up there. It allows me to put markers on the screen as to what I'm looking at on the screen, as well as it allows me to do network filter sweeps and things of that nature. Very handy to have around when you're trying to identify spurs or mixing products in a transmitter. So it's a very specialized piece of equipment, but if you do a lot of transmitter work, very good to have around, or even for receive work, is that for that matter of fact, you know, for looking at mixing products. Transistor tester. This is my transistor tester. It's a Cricket TF30. This was made by Syncor. The nice thing about this transistor tester, it can test both in and out of circuit semiconductors. It's got a quick no-go, no-go test on it, so that you can quickly identify a bad semiconductor in a circuit, or you can actually look at the beta of specific transistors with it. If you have a transistor with low gain or low beta, this allows you to identify it fairly quickly. Inductance meter, I showed you my DER earlier. That's my handheld inductance meter. This is my larger bench inductance meter. This is an LC75 Syncor. It's a capacitor inductor analyzer. It does ESR as well as checks for leakage and value of capacitors. Primarily, I use this one out of circuit. You can use it in circuit, but it's more accurate out of circuit. The one thing that this meter does, which my DER will not do, is it allows you to ring inductors. That's not something that many people do as much these days, but if you're working on CRT circuits or anything with a flyback transformer in it, or any type of ringing system, you want to be able to ring the inductor to make sure the inductor is actually good, because you can get shorted turns in an inductor software. Once again, it looks fine, it acts fine, the resistance tests fine on it, but it doesn't work. This is the Variac that I typically use the most on the bench. This is one that I actually built. It's built based on the Superior Electric variable transformer. It also has meters in it that show me the current draw of the up to 5 amps, the device I'm working on, as well as the voltage that I'm feeding it. This allows me to adjust the voltage going into the device and see how much current is drawing at that voltage. So very handy for working on older equipment that hasn't been energized in a number of years. This is an AC current limiter that I typically use with the Variac. Basically, it's nothing more than a series light bulb. That's all it is. And you can screw different light bulbs into it depending upon how much you want to limit the current going into the device you're working on. And then finally, the signature analyzer, which I talked about a little bit before. This is my signature analyzer that I use. It's built on an old RCA W033A. But it has a Windbridge oscillator in it, that allows me to actually use it as the signature analyzer. And right now, I think I'm just looking, I just got a capacitor hooked up to it. That's the pattern you typically see with a capacitor. So let's move down to expendables. I think the last few sections I had were in items that you probably want to keep around your shop, not specifically tools, but items that probably you need to have in your shop. In expendables, I routinely use the following items in my shop: contact cleaners, flux remover, freeze spray, isopropyl alcohol, electrical tape, machine oil, and penetrating oil. Those are all the things that I would consider essential to have around as expendables in your shop. For contact cleaners and freeze spray, I really like MG Chemicals. However, there's a lot of different vendors out there that sell it. Deoxit is particularly good for cleaning old switches and things and older tube type gear. And moving contact lubricant, or MCL as I call it, that's also made by Deoxit. That's good for cleaning potentiometers that have gotten dirty. Flux Off is, I think, also made by MG Chemical. That's a flux remover. Primarily I use that for removing flux from PC boards. And freeze spray, if you're chasing a thermal problem in something, you definitely want to have some freeze spray around that allows you to quickly cool a component or an area down in the circuit to determine if that particular area is the area that's giving you problems. I use that in conjunction with a heat gun to actually identify thermal problems in a piece of gear, because that way you can repetitively heat and cool a specific area of the circuit that you're working on. Isopropyl alcohol, probably one of the best things to have around for just general purpose cleaning. 91% through 99% is what I recommend. 91% you can pick up at most any pharmacy or many variety stores locally. It's fine for doing general purpose cleaning. If you have something where you really don't want to leave a lot of residue, you need 99%. However, you basically have to order that. I don't believe there's anywhere locally you can pick that up. Electrical tape, I like Scotch 88 Plus and Scotch 33. It tends to hold up good to weather. It doesn't delaminate and come apart like a lot of the cheaper electrical tapes do. For machine oil, I've used 3-in-1 oil for years. It works great. Never had any problems with it. And for penetrating oil, PB Blaster and Liquid Wrench are probably my two go-tos for penetrating oil. When you got to get a stuck machine screw or a stuck screw or a U-bolt on an antenna loose, boy, those things are just worth their weight in gold. In other expendables that you may want to have around your shop, lithium grease, which you need for lubricating shafts and linkages. Goo Gone, if you work on old gear that has sticky labels on it or anything like that, you're going to want to have Goo Gone around. I use a lot of Windex for general surface cleaning. Acetone is something that I use occasionally, more often for PC board surface cleaning when I'm etching PC boards. However, it's also handy for paint removal. You got to be careful with it because it can damage plastics. Q-tips and swabs, particularly useful for switch cleaning and lubrication. And then for glues, probably the glues I use most often are epoxy, silicone sealant, and thread locker. In discrete components, no workshop is complete without a selection of discrete electronic components. Those are needed for general replacement and for prototyping circuits. It's particularly important since there are now no locally available sources for most of these items. We used to have, back in the day, we used to have here in Raleigh, Capital Electronics and of course Radio Shack and a few other places where you can pick up items. But most of these places are now out of business, and I think the places that are in business don't carry components anymore. So it's good to have a selection of components around to be able to work on things so you're not waiting on stuff all the time. I recommend purchasing general assortments of each item as being the most economical way to keep a good supply available on hand. So the next listing I'm going to show you are the specific items and some of the suppliers that I use for them. In components, there are capacitors, resistors, LEDs, potentiometers, switches, diodes, transistors, linear and digital ICs, and machine hardware. Listed beside each one of those, you'll see the suppliers that I actually use for specific components, which are not in parentheses. And then the ones that I use for assortments are in parentheses. And if you're not familiar with some of those suppliers, probably my go-to for specific items is probably Newark Electronics. The nice thing about Newark is their main East Coast warehouse is in Gaffney, South Carolina. So that means when you need to order something from them, typically even with their standard shipping, you'll get it within 2 days. So that's one of the nicest things about Newark. And they have virtually every component that's current production in stock. They're not the cheapest out there, but basically you can get it quick and you know it's first quality. Of course, Mouser, many of you are probably familiar with them. They're located in Texas. They're fairly quick too. They have most current production components in stock. Of the surplus suppliers that I use, MPJA is Marlin P. Jones Associates. They're located in Florida. You can look them up on the web. They're a very good surplus company. Of course, Electronic Gold Mine, they're a division of Cheney Electronics. They're another very good surplus supplier. And then All Electronics is out in California. They all stock assortments of all the items pretty much listed on the left there. So like I said, I recommend if you don't have a good supply of, say, capacitors or resistors in your workshop and you want to stock up on some, go check out some of the surplus suppliers that are listed here, because they've got assortments that are very, very reasonable that you can pick up usually for $10 or $12, or, you know, maybe less than $20. And it'll give you a good stock of items that you can use in your workshop. For machine hardware, at the very bottom, I like Bolt Depot and Micro Fasteners. Those are my two go-tos for machine hardware. You can get some of the machine hardware locally at some of the local hardware stores. However, Bolt Depot and Micro Fasteners tend to have anything you need online. They're fairly quick to get it to you. They also carry specialty hardware. Like, for example, if you're making, say, an end-fed half-wave box, you can order stainless steel hardware from them in machine hardware, and they will have that in stock. The hardware I typically use the most on my workbench is 440, 632, 832, and 1032. Okay, let's see. That brings me down to workshop organization. I believe this is going to be the last category I'm going to cover in this presentation. Workshop organization is very, very important. It's something that I struggle to do all of the time, because as you work in the workshop, things tend to get disorganized. And the more things get disorganized, the longer it takes you to get anything done in your workshop. In fact, early on when I was doing electronic repair, I often found that it took me longer to find a particular component than it did to identify it as being bad in an item I was repairing. And so I've worked fairly hard to try to get the workshop organized, and it's a continuing struggle to try to keep it organized. The things I use for organization in my workshop are cabinet organizers. Basically, you can get those from Lowe's or Amazon. Arco storage bins. Those I use a lot of. I like Global Industrial, which is down in Miami. You can order from them off the web, or I think you can order also mail order from them. Of course, Harbor Freight and Northern Tool also has those, but they're a lot more expensive from either one of those places. Small parts organizers, Lowe's and Home Depot has a good supply of those. Shoebox organizers, the same, Home Depot and Target. And large storage containers, also Home Depot and Target. So let's take a look at a few of those. Okay, these are some examples of Arco bins. Let me take my pointer here. These are Arco bins right here. The nice thing about Arco bins is that they hold a lot, and you can put a label on the front of them. I use these machine produced labels, but you can actually put a I think a little small card label in there as well if you don't have a labeling machine. And the other nice thing about these is they stack. You can stack them one on top of the other. So I think I've stacked them up to 4 or 5 high without any problem. And then these are some examples of storage drawers that I use to store like some of my capacitors, my Mylar capacitors in, and some of my general purpose connectors and things of that nature. These are my larger Arco bins. I use these for storing wire and storing large can capacitors and storing electrical tape and supplies and things of that nature. The nice thing about these is, once again, they stack, so that makes them kind of handy. You can also put, I don't know if you can see it here, but you can also put dividers in them. So you can actually split one bin up into 2 bins, which is kind of handy if you don't have something to fill up a whole bin. These are my smaller part storage. All of my machine screws are stored up here in the small part storage area. A lot of the components I use are stored down here in the Arco bins and in the shoebox storage area. In the small part storage, this is how I organize my small parts. This is another example of how I store Mylar capacitors, and it allows you to label them by voltage and by value. So it makes it real handy to find them when you need them quick. Shoebox organizers, larger components such as RF connectors, XLR connectors, parts bags, etc., etc. I store these all in shoe boxes. Makes it real quick to find. You can label each one of them, so that way when you go over to your shelf to grab one, you know exactly what you're getting and where it is. And so that brings me to the end of the presentation. So I'll go ahead and see if we can stop the share here and get back to where we're supposed to be. And if anybody has any questions, we'll be glad to answer it.
Hey, Bill,
Yeah.
I'm sorry, go ahead.
Go ahead.
Hi, Brian.
Go ahead, Brian.
Okay, I was wondering, we had a recent situation where somebody was trying to glue a wafer back in a variable cap, and he was using, what is it, weld, GB weld?
AB Weld.
Yeah, AB weld. Well, have you used any of that new UV glue like dentists use? You know, where
I have not used any of that myself. However, I've heard it's particularly good for certain applications because, once again, it's you can put the glue in place and it doesn't cure until you put UV light on it. So if you need to move something around and make sure it's positioned exactly right,
Yep.
it sounds like to me it would be a good thing to have around the shop for specific repairs.
Well, I've been going to the dentist quite a bit the last few weeks, so. But okay, great presentation, by the way.
And one other thing I'll add in glues too is there's another glue which I wasn't really familiar with, and I think I saw it the other day. I believe I was watching, believe it or not, Ask This Old House, and I think Tommy was replacing a deadbolt in a door, and he used a glue it was a polyester glue, and it's water activated. And the neat thing about it is that you put this glue in the plug where you wanted it, and then you wet it. And when you wet it, it expands and fills the space. And then once
cool.
it fills the space, it hardens up. So that's another item that I'm going to have to investigate some more that might be of use.
Okay, great. Thanks.
Mm-hmm.
Any other questions?
Yeah, I was going to ask him what he does with his spare time, but I don't think he's got an answer for that. Good presentation, Bill.
Well, the nice thing about it is it's you know, I've heard a lot of people say, oh, well, with the pandemic, I'm bored because I can't get out and I can't do anything, etc. So I haven't even noticed.
They say with us old folks, you know, the biggest thing is cave syndrome, where we're getting used to being in our cave and maybe we won't come out, you know.
Oh yeah, I know what you mean.
Bill?
Yes, sir.
Maybe I missed it, but did you have any magnifier for surface mount work?
Yeah, I actually do. I actually have a, and I don't know if I can show you this or not. Let's see if I can grab the camera, and I don't know if I can actually show this to you or not. If I got enough cord on here to show it to you, I'll turn it around over here, and let me apologize for all the junk there. This is what I use for doing surface mount stuff. This is a Inspector Super Scope 2000. It's made by OC White, and it's basically an electronic, it's basically a television type microscope, magnifying microscope, and it has a LED illuminator underneath it, and it is on a swing arm, which probably you can't see real well there because it's kind of buried behind a bunch of junk right now because I haven't been using it lately. But basically, that's what I'm using when I'm working on surface mount stuff for the most part. I do have actually some headset magnifiers that I use and things of that nature, but I find myself using the the video magnifier more so than anything else, just because it's got good magnification, and it's pretty handy to use on the bench because I can just pull it over here when I'm working on the bench, you know, on a piece of surface mount gear.
Yeah, very good, Bill. I used to do surface mount work. Used to work in avionics. We used to. I worked in an engineering lab, and they sent me to school for it, and they certified me. But we had some pretty good equipment, you know. Well, I'm doing this stuff at home, and I have the head magnifier too, but I don't really have the right soldering the irons for that stuff. So I really haven't done much of that in years. But we had all kinds of good stuff that we did stuff.
Well, a couple of things I didn't show, and like I said, I wasn't going to specifically cover surface mount in this because that's more of a specialized area. But I've got a hot air workstation that I use for doing surface mount, which is over on the other side of my workbench over there. And I've also got a set of hot tweezers as well that I use over there.
Oh yeah, that's nice to have.
Yeah, so basically those are real handy for you know, for doing surface mount repair work. And then of course I've got a large selection of tweezers of different various types that you can use to actually with a hot air gun to actually remove components and put components back on the board, as well as a reflow oven. The reflow oven that I've got is it's a home built reflow oven, and I built it out of a toaster oven. It works very well. As a matter of fact, I've got a little temperature control unit on it that keeps the temperature right where you want it. And you can put your boards in there, and it works very well for reflowing stuff.
Yeah, we didn't have a reflow oven at work. We didn't really do that kind of work, but we were doing pretty well. We had like 4 or 5 setups in the lab for people to work.